Hello, ladies and gentlemen. Today we're going to talk about AA similarity and what that means. You're going to want a calculator, a pen or a pencil, and your foldable that was given to you in class. So to know that triangles will be similar, we need to know that all the angles must be the same. If you know that all the angles are the same and then the sides will be proportional, you don't even have to check them. So if all of the angles are the same, then we know for a fact that the sides will be proportional. So you won't even have to use any of your ratio skills or proportion skills to make sure that they're proportional. We would already know that. This is what we call the AA similarity. Now we don't use all three A's, we just use two because we have a theorem that tells us if we know two angles are congruent, then we know that that third one also has to be congruent because we know that every single triangle adds up to 180 degrees. So here's what we call the AA similarity. If we know that two angles for sure are congruent, then we know that the other one has to be congruent. So this is what we call the AA similarity. Again, two angles similar, two angles are congruent, then we know that the triangles are similar. So what AA is telling me is if I have two triangles, again, this is AA similarity. If I have two triangles that have two angles that are congruent, so right now we would have angle K congruent to angle Y, and we would have angle J congruent to angle X. So if this happens, then it's safe to say that those two triangles are similar. Notice this notation is subtly different from our congruency statements, but again, we would know these two are similar when I know that I have two angles that are congruent. So how do we use that with what we're doing in class right now? So we need to figure out if these two triangles are congruent. So we got to do some thinking here. Just like improving, is there any information that we can deduce? Any information we can figure out based on just what my picture is showing me? If I look here, we would all know that we have a set of vertical angles. And notice I have these arrows right here, and with these arrows, that means that those two lines are parallel. So when I have parallel lines, remember that we can pull out either alternate interior or we can pull out corresponding. So corresponding, they'd have to be on the same side of the transversal. And if I just think about this transversal right here, it looks like the angles that are inside the triangle are going to be on opposite sides. So if they're on opposite sides, it looks like here I'm going to have a set of alternate interior angles. So when I look at all this and I deduce this information, then yep, I can prove that these two triangles are similar using AA similarity. Again, they have two angles that are congruent, so they are similar using AA similarity. So then what I want to do is write a similarity statement. So I want to say that triangle GKH is similar to triangle NKM. And again, I just have to be careful about where I put those letters because I have to make sure that the corresponding letters are congruent angles. So G would have to be congruent to N, K in the middle would have to be congruent to the other K in the other triangle, and H would have to be congruent to M, which when you look at these triangles, it looks like that is correct. So let's try another. So in this next example, again, we're going to want to check to make sure that we have any information we can deduce. If you look at the angles that are given to us, it looks like angle B is going to be congruent to angle E. And then it looks like angle F is 55 and angle A is 77. So those two can't be congruent to each other because obviously they're different angle measures. But we could figure out the third angle in both triangles to figure out if we have other congruent angles. So if I were to figure out angle C, I would take 77 plus 48. That would give me 125. Then I would take 180 minus 125, and that would give me 55. So if you notice there that angle C would have to be congruent to angle F. So right off the bat there, it shows us that we have two sets of congruent angles. So we can use the AA similarity theorem to help us prove that these two triangles are similar. So once I know they're similar, again, we got to make that similarity statement. So triangle ABC would be similar to triangle A goes with D, B goes with E, and C goes with F. So again, once I showed that they had two sets of congruent angles, I was able to show that the two triangles as a whole would be similar to each other. Excuse me. All right, in this next example, we have to figure out again if these two triangles are similar. It looks like they already give us that we have one set of congruent angles, but now we got to figure out the others. So in this bottom triangle, it looks like we already have two angles given to us, so it would be a really quick find to find what angle E is. So let's go ahead and do that. I'm going to take 53 plus 33, which gives me 86, and I'm going to subtract that from 180, because there's 180 degrees in a triangle, and this angle is going to be 94 degrees. So if this angle is 94 degrees, I think it's safe to say that this angle up here is 94 degrees because they show me that they are congruent. So now I know that one angle in ABC is 94 and the other angle is 32. So if I add those together and subtract that number from 180, we are going to get 54. So angle A right here is 54. So when I look at these two triangles, do we have similar triangles? I have one set of congruent angles, but no other sets of congruent angles. So I think it's fair to say that these two are not similar because I can't prove that two angles are congruent. All right, so in this next slide, we need to determine that they are congruent. If you notice here in the pictures that are given to us, we are given that two sets of angles are congruent. So by AA similarity, it's safe to say that these two triangles are similar. So when I finish off this triangle similarity statement, M corresponds to G, O corresponds to H, and N corresponds to I. So I finished that off. Now it wants us to fill in the blanks here. So side MN looks like it's going to relate to GI. Side ON looks like it's going to relate to HI. And side MO is going to compare to GH. So again then, let's look at 16. So it's talking about 16, which is ON. So ON right here compares to HI, and HI is 12. So I'm going to fill in that first question mark with 12. Now we have blank comparing to OH. Again, since I went from 16 to 12, again I have to go from the bigger triangle to the smaller triangle. So the smaller side, the smaller triangle has 10 as that bottom side here, excuse me. So if that bottom side is 10, then the other side, if I were to go back here, it looks like I'm comparing that side to MN. So MN is my X value. So again, at the bottom here, it wants us to end up solving for X and Y. So if I have 16 over 12 equaling X over 10, here I have two ratios set equal to each other. This is what we call a proportion. So we want to cross multiply. So I'm going to get 12x equals 160. So I'm going to go to my calculator and I'm going to take 160 and I'm going to divide that by 12. When I do that, I get a repeating decimal. So we're going to want to leave it as a fraction, 160 over 12, and end up reducing that. So it looks like I can pull out I think I would be able to pull out a 4 from both of them. Let's try 4. So 160 divided by 4. That gives me 40. So x equals 40 over 3. Now, does 40 divide by 3? I don't believe it does, so we're going to leave it as 40 over 3. So let's look at this next ratio or proportion we need to set up. So it looks like now 16 is on the bottom, so it looks like this time, I'll change colors, but this time we're going to go from small to big. So 16 relates to the 12, so 12 would be on top here. And then we have 8 relating to y, so 8 over y. And if I were to set this equation up over here where it's a little bit easier to see, 12 over 16 has to equal 8 over y. So when I go to solve this, again, I want to cross multiply. So I'm going to get 12y equals 16 times 8 is 128. And again, then I want to divide by 12. So 128 divided by 12. Again, I get a repeating decimal, so we're going to leave it as 128 over 12. Again, I'm going to try 4 going into both of them. 4 goes into 128 32 times, and it goes into 12 3 times. So again, it looks like 32 doesn't divide in nicely, or 3 doesn't divide in nicely to 32, so it looks like my y value is going to equal 32 over 3. So if you have any questions on this one, make sure you start and write those questions that you have so we can revisit it in class if needed. So where might we see this AA similarity used in the real world? In low light camera lenses, they use similar triangles. So if you see that picture that's located there on the right, the camera lens, we have a bow tie shaped pair of similar triangles. Note that the light passes through a camera lens and the original image ends up upside down or inverted. This is why the camera has a mirror that then flips the image right side up so we can view it while we are taking the photo. It's very important that this mirror is kept spotless because when we're cleaning the lenses, we must be careful never to touch it with our fingers. So again, when you take that picture with your camera, it reports it in your camera as upside down, but then your camera is smart enough to flip it right side up. So how might we use this as we move forward? So here in a real life example, we have the height. We want to find the height of a tree. So a mirror is placed on the ground. You back up until you can see the reflection of the top of the tree in the mirror. So we want to ask, why are the two triangles similar? Now, if you notice, this person standing with the ground is creating this right angle here, and the tree with the ground is also facing, or is also creating this right angle here. Now, the angle you're looking down on the mirror is the same angle as you are looking up here. So if you notice here, this angle would have to be congruent as well. So these two triangles are similar using AA similarity, because the angle you're looking down is the same as the angle that's reflecting up over here. So these two angles have to be congruent. So now we can use our AA similarity. Since we know that the triangles are similar, we can set up a scale factor. So the bottom 3/24 has to be congruent to 5.5 over x, because x is the height of the tree. We can make this height of the tree x. So when I go here and I start to cross multiply, then I get 3x equals, if you type in your calculator, 24 times 5.5, you should get back the number 132. And when I divide both sides by 3, I get x equaling 44. So this tells me, since x was the height of my tree, that the height of my tree should be 44 feet. Again, I was able to use AA similarity because these bottom angles must be the same when you back up to see the top of the tree. And then when you compare those similar triangles, their scale factor, again, if they're similar triangles, the scale factor has to be the same. So 3/24 would have to be the same scale factor as 5.5 over x. So again, the height of the tree should be 44 feet. All right, so this indirect measurement is one that we're going to quickly do here. Again, this is kind of like that camera lens and how it flips it a little bit upside down. We can assume that these two triangles here are similar because since we have two 90-degree angles and these ones are going to be perpendicular to each other, then we can consider that those lines are parallel. We have a theorem that we've talked about in the past that tells us that. So these two angles here would be alternate interior angles. So these smaller triangles are similar by AAS. So I'm going to try and figure out what this little segment here is. And again, we are trying to find the diameter. So once I figure out just this radius, we're going to have to double it to find the whole diameter. So if I were to take this one, if I cut this whole diameter of the smaller circle in half, it's going to be 0.6. But notice over here we're talking about centimeters, and on the left we're talking about kilometers. So I'm going to have to change these centimeters into kilometers. And the conversion rate that tells us to change it into kilometers means I have to move this decimal place 5 places. So that would be 1, 2, 3, 4, 5. So this one would be 0.002 centimeters. And if I take this one and move it 5, we go 1, 2, 3, 4, 5. I should have 5 zeros in front of my 6, not including the one out front. So 0.00006 all over. I'm going to compare that to x. So x is going to go on the bottom because this bottom side compares to the bottom side over here. And then I have 0.002 comparing to 150,000,000. So when I set up this problem, it looks like the numbers are going to be pretty big, but they actually turn out pretty nice. Again, we want to cross multiply, so I get 0.002x equals, when you take that big number and you multiply it by 0.000006, you get back the number 900. And then when you divide by 0.002, you get back 450,000. Okay, remember this is just that radius of the sun. So if I wanted to find the diameter of the sun, I would have to multiply this number by 2. So when I multiply that number by 2, we get 900,000 kilometers. So this is how you could figure out the diameter of the sun, is using this little experiment. So hopefully if you looked it up, the sun is about 900,000 kilometers. So I want to thank you for taking good notes. I apologize for a little lengthy video, but we can revisit any of these concepts in class if you have any questions.